Welcome to the Structured Finance Hackathon 2026. My name is Luca. I'm one of the organizers of the hackathon. I'm here with Sriram, who's also helping us with different things. This year hackathon is taking place on June 10th in Barcelona, but also virtually. If you want to demo your prototype, you can do it virtually as well. So let me walk you through the second challenge. Last week, Hyperport presented the agentic framework challenge, and this week I want to present the second challenge, which is the credit foundation model. So why now, and why the credit foundation model? So a bit of history about myself first. I started working with AI models and credit data back in 2018 when we were training from almost from scratch temporal transformer, a fusion temporal transformer with credit data. And back then we spent some money on compute, data licensing, and then we went to a market, and the feedback wasn't really great. So we really failed the go-to-market. And why? Well, two main reasons. First, because the technology was less developed. We didn't have the tooling that we have today. And also because back then AI wasn't really a thing, at least in financial services. We were trying to sell an AI model to chief risk officers and chief lending officers, but they had no idea how to bring in this AI model into their firms because there was no governance. Today, this is very different. So today, the technology has exploded. We have lots of open source technology out there, some NVIDIA technology, other firms pushing open source libraries out in the open. And this is great, right? Because it lowers the bar. At the same time, AI governance is a top priority. AI governance is discussed in the boards of these big financial institutions. So when you talk to a chief risk officer in a bank or a chief investment office in a investment firm, they definitely know what you're talking about, and they want to learn more because they have a mandate from their board to understand how AI is going to affect their firm. So that's why we think this is a great time in history to build something like this, to build a model that is natively trained on credit data, specifically loan level data, invoice payment data, and similar data. So this is the background. This is nothing new, meaning that Revolut and NVIDIA earlier this year released a model specifically for payments, and they also released a blueprint for this model. And what they've done is very simple. They took the data, they trained a model, they produce embeddings that are specifically for payments, and now those embeddings can be used in different use cases downstream. And what we want participants to do this year, the hackathon, is very similar, right? There are loan level data with loan events. So is this borrower paying on time? Is this borrower defaulted? As the bank recovered any amount from the defaulted borrower, and so on. So take this data, tokenize it, train the model, produce the embeddings, and bring the embeddings into the use cases, the workflows. So this is basically the similarities. So here we go. This is a challenge statement. The title is Credit Foundation Model. There is a bit of information in the background. We suggest to use the transaction foundation model blueprint from NVIDIA as a guideline, as a starter. We also have libraries that we build, notably Deeploans. There is an ETL pipeline generator. There is also a synthetic data generator that Sriram is going to showcase in a second. And the question is, how might we build an open NVIDIA-accelerated credit foundation model that converts loan-level histories into reusable embeddings for default, loss given default, recovery, and cash flow workflows? Most importantly, with governance, right? So that banks can actually use it. The prototype is can be seen in these 5 stages. So ingest and normalize the data, validate and enrich, create the representations, and then use the embeddings into the use case or the workflow. And last but not least, create the governance around it. This is an example of what in the NVIDIA stack can be used to solve the challenge. You are free to use any tool that you want, and we have Hackathon resources for you. So just ping me and we share the Hackathon resources, like access to Scaleway or data and so on. This is a bit of a deep dive on the Deeploans. Deeploans helps you to move from raw data to more enriched and usable data through the different 3 layers of data transformation. So bronze, silver, and gold. And once you have done your embeddings, we suggest you to showcase the prototype in the context of a real use case, because it's easier for the judges to see and appreciate the usefulness of your work. So once you have done the embeddings for the credit foundation model, maybe you can plug the embeddings into a early warning dashboard or a data quality scoring dashboard. Up to you. This is a 2-week sprint. I mean, we are already a week in the hackathon, so there is a week left. This is a suggestion how to move from the kickoff to the data loader and baseline to the tokenizer embeddings, and how to bring governance into the demo. Remember that the demo is next Wednesday at 4 p.m. and you have to register in the AI Tinkerers platform and create a team. Can be also a solo team before June 9th, next Tuesday. So for the winner of the hackathon, specifically for this challenge, we, Algorithmica, provide an incubation program whereby we will provide access to NVIDIA resources and for 60 days. And after that, we will also help the winner to prepare the VC incubation application. So I stop here and I hand it over to Sriram.
Thanks, Luca. Let me just quickly share my screen. Hope I'm audible, loud and clear. Thank you.
Yeah, you are.
Okay. So probably let me just start with a brief introduction of myself. Since I'm sharing this, I'm not able to see the screen. So Luca, let me know if I need to stop or anything. So myself, I'm Sriram Krishnan, and my background is in data architecture and analytics, predominantly with banking. So for this use case, what we have built is basically a Dutch residential mortgage data set. So this residential mortgage data set, what we have done is for 24 months. So basically from Jan 2024 to December 2025. So we have built 24 monthly snapshots of data. So we have started with 500K loans. So basically we have started with a initial transactional data set volume of 500K loans, unique loans. And then we have gone through 24 months progression of the loans. So you've got some numbers here. So we have ended up with 11.2 million records. That's the total volume of the data set for 24 months. And we have built it across for 71 columns. I'll go into the column details in the next slide. And we have just gone with some random aggregate balances. So you have started with euros 162 billion, and then towards the end of the 24 months, we have ended up with $197 billion. Sorry, euros. So this column schema is kind of quite exhaustive. So you've got like, so this is, we have bucketized it into lots of other things, but it starts with the unique loan identifier. It goes into all the other things you expect from a mortgage data set. So you've got the loan to value, valuation, loan economics, affordability, payment frequencies as well, and then the borrower and the property types. And then we've got some pre-computed buckets. So all the data is available on GitHub. So we've got an exhaustive list of the column definitions as a glossary. And so this data set, so we have started with 500K loans, and then we have kind of like gone through the whole life cycle. So it's not just that the loans are kind of falling off or not unique. So this 500K loans, the whole duration for the 24 months are going through this life cycle. So either they're kind of like completed or reading or going into default state and then charged off. And then when they are getting charged off, there is not going to be any amortization. Basically, the balances don't get reduced. And then this 500K loans journey is throughout the dataset, which is useful for training the model. Okay. So just a few caveats on what this data can do and what this data is not. So this is kind of like a pre-calibrated data set. So we have kind of gone in with some assumptions like what is the delinquency rate we have gone with, but we have ended with the delinquency rate that's a bit more than the average. So I was looking at the Dutch delinquency rates, it comes around like 0.6%, but then our data sets comes around 3.5%. So you need to be really aware of what this data is. So if you're going to train the data, I would assume that I would prefer that you go into analyze the data, get an understanding so that this is what the data is. So, and then again, right, so we have gone with some kind of transition matrix because the data is transactional in nature. So we kind of have gone with some pre-assumptions, as I mentioned, right? So we have gone with like say 3.5% delinquency rate, so that the whole loans are about 3.5%. These assumptions are not real world. So basically, for example, your 2008 delinquency rate would be much higher than the rest of the year, right? So it's kind of like nowhere near real data, right? And then always reality often throws up surprises. So you are kind of like so you just need to understand, right? If you're going to use this tool to produce the data and then you are going to generate it, just go about with 2 or 3 iteration and variations that mimic the real world. Because real world data is hard to come by, so we are kind of like trying to do this. So that's the another point, right? So again, right, if you can, I think this was for pre-training, stress testing, everything is fine. But then if you're going to ship around, then probably you need to kind of have access to real data to do it. And one of the things this tool kind of right now has is called parallel collisions. So basically, when you're trying to randomly generate unique IDs, so it ends up with some duplicate IDs because of collisions in the random thing. And this is because like we have kind of like unique IDs that is restricted to a certain data length. So this one is kind of like fixed for now, but then just ensure that whenever you are regenerating using this tool, try to run some tests. So the tests are also in the it has got already like a pre-generated set of tests, but if you want to add, you can always add it and then do it. Okay, so these has got the, so we have got the data set. So I got like 24 months of CSV data in Hugging Face, and we have also got a single Parquet file that is closer to 1.2 GB that has got all the data available. So the data is available on Deeploans GitHub. So you can go through the README, and then also, as I mentioned, you've got the column glossary that has got the definitions of all these 71 columns. So I also kind of included a predefined set of stats that gives you an initial understanding of what this data is. And if you need to run it yourself, so it has got all the instructions in the README to kind of run it. That's it about it from the definitions on the tool. Any questions? Stop sharing.
Would you, Sriram, can you please share the repo and where the tool for generating more data is? I can put here in the chat the two links,
Sure.
but if you can open them and share your screen, would be great. Just walk them through it. Thank you.
Yeah.
So
okay. So the tool is available inside the Deeploans GitHub, and as I mentioned, it has got these exhaustive README. Thanks to Cloud Code, you don't need to do it anymore, so it kind of helps a lot. So basically, it has got like the data designer. So the data designer is basically, if I want to go into the details, so the data designer produces the initial batch of 500K loans, and basically it has got all the regions, all the data, and all the knobs, like how do you do it. So we have kind of used both NVIDIA NeMo data designer. So it's basically a tool that kind of does column to column referential integrity, basically meaning that it forces the columns to kind of, like say if you have a region and you have a sub region, then it forces it to kind of map it. So those kinds of things we have gone using NeMo. But then the most important thing you need to do is basically you need to kind of do row level referential integrity, right? So basically you need to ensure that the row every time it kind of like ages for each of the months, then you kind of have a reducing balance, or you kind of go into delinquency, charge off, and those kinds of things. So age to panel does this. So how this tool works is probably just, yeah. So basically, you kind of have the initial data designer kind of does the initial 500K loans, and then you kind of pass through a set of Bernoulli processor, Gaussian. So for kind of doing the different sets of transformations. So this ensures that basically you kind of like not lose the record level integrity, because if you're going through randomized things, then probably it loses every time. So it ensures also the loans kind of balances and everything are reduced, and there is kind of like not too much drift. And finally, it produces a synthetic data tape, and then it finally also produces a single Parquet file. Any questions so far? silence us. No. Hi, Ali. Yes.
Apologies for the background noise. Hopefully AI is helping reduce that in this call. Let me know if you can't hear me. So with my team for this hackathon, we are thinking about a use case for green loans. So these are loans for example, building retrofitting, etc. Do you think this database could cover this specific type of loans, or is it more typical consumer credit or company credit kind of database? Thank you.
Yeah, sorry, it was very hard to hear, but I would assume your question is regarding whether you can use this data set for this hackathon use case. Is that right?
No, I think the question was also whether the scope of the data can be used for retrofitting. So if there is a borrower that is borrowing money for retrofitting its own house, can this data be used? In I think the answer is yes. No.
Yeah, I think we can keep adding to it for retrofitting and other things. So one of the things right now this use case doesn't do is doesn't add new loans, but probably you can just keep on. The repo is under a public license or Apache license, so you can kind of fork it and then add to it, and it's compartmentalized as well, so you can have this kind of expand it as you wish, and also fine tune the different rates you want to have.
Thank you. Maybe a follow-up question, and apologies if I missed this. I guess, what is the scope of credit products and final users that are covered in this database?
So this one only covers Dutch residential mortgage. I think the referrer is ING, I guess. So I got an initial seed data set that kind of expanded on. But then if you want to use a different seed, you can kind of expand on top of this. So let me kind of try to go into again phase. So you can go here and then look at the data explorer. So basically it's kind of everything is a single loan class, green line loan.
Great, understood. No, thanks. This gives a bit more context on the uses for this database.
You're welcome. That's it from me. Over to you, Luca.
Super. Thank you, Sriram.